Now what we're going to do is look at JK flip-flops, and while we're doing that, we're going to look at function tables and excitation tables. JK flip-flops are useful in little finite state machines like we're talking about. Whenever you talk about bigger computers and registers and things like that, D flip-flops are more prevalent, but JK flip-flops are useful nonetheless, and it is something that you need to be used to talking about. If we remember the SR latch, it had its S and its R, and then we had our Q output here. The great thing about that, if we were to look at its function table, and the function table just means how does the thing function with certain inputs. So we have S and R as our inputs, and then we have our output, a table like this. And so we have 0, 0, 0, 1, 1, 0, or a 1, 1. And this means that we were going to hold. That means our Q plus is, we're not going to call our output, we're going to call it our Q plus, is equal to our old Q. Our new Q is equal to the old Q. We're just holding. 0, 1, we're resetting, so we're setting it to a 0. A 1, 0, we're setting it to a 1, 1, and this is an invalid input. Now, there's two improvements for the JK flip-flop. One is it's a flip-flop, so it's edge triggered. It has a clock on it. But the J and the K, the J kind of is synonymous with the S, and the K is synonymous with the R. But the JK flip-flop, it does not have that invalid input anymore. It now has the ability to deal with that 1, 1. And so its function table, so the JK flip-flop function table, it's like this. We have JK, and then our Q plus, like that. And we put 0, 0, we just get Q. So it's a hold again. So we have hold one more time. 0, 1, it's a 0. So that's a reset. And then we get 1, 0, we get a 1, so that's a set. And then we have a 1, 1, which is going to be Q bar, which is toggle. And that's the function table of the JK flip-flop. It's similar to the SR latch, except one has a clock, and then two, this invalid input because of the race condition on the SR latch. You never know what you're going to get, depends on which one shuts first. That you don't have to worry about here. You put a 1, 1 in, and you're going to toggle the output. Now, that is a JK flip-flop. What we want to add in addition to that, as far as tools to use the JK flip-flop, we want to use something called an excitation table. Now, what this table says, it says, I'll tell you what I currently have, I'll tell you what I want to get to, and then using a particular type of flip-flop or latch, what inputs do I need to get there? So for instance, if we have a 0 on our Q, but we want to change it to a Q1, we want to hold it to a 0, what inputs could we put on our JK flip-flop to go from 0 to 0? Well, if we look back up here at our function table, we can either hold 0, 0, or we can reset 0, 1. So we can hold. I don't know if that's going to work out. Maybe that's not a good idea. I thought I'd be clever. Yeah, that's not going to work too well. At any rate, you can either hold or reset. So that is 0, 0, or 0, 1. In other words, as long as J is 0, then it doesn't matter what the K is. It can be 0 or a 1. So we don't care. So we're going to put an X there. So to go, if you have a 0, you want a 0. You just have to make sure J is a 0, and it doesn't matter what K is going to be. Well, how about if we have a 0, but we want to get a 1? What then? We can look up here and we can say, well, that's a set. We can either set it, so 1, 0, or we could toggle, because we were at a 0, now we want a 1, so we could toggle that. So we could go 1, 0, or 1, 1. In other words, as long as J is a 1, we don't care what the K is. Now, The next one is if we have a 1 and we want a 0. So that means, again, we could toggle or we could reset. So we have 1, 1 for toggle, and reset, we have 0, 1. So in other words, in this one, as long as k is a 1, we don't care what j is. So we're going to put a don't care for j, and we're going to put a 1 for k. Then let's see here, we have 1 left, that's 1, 1. That means we can either hold or we can set. Hold is 0, 0, set is 1, 0. So k is 0 in both cases, and j doesn't matter. So we're going to put j, x, and 0. That's an excitation table. We're going to find out that this is incredibly useful in the future. We're going to find that this excitation table is a really powerful tool that helps us fill out our state transition tables whenever we're solving for a finite state machine. Now, one last thing real quick is if we want to do a couple of things in Canvas, I mean not in Canvas, but in Cedar Logic, I have here a Cedar Logic circuit here. And this is a little bit different than what you've done before because I've put these connectors on here. So I still have input A, and whenever I have input A, you can see that this line lights up. And whenever I click it off, it goes off. When I put input B, you can see input B here, it lights up. And when I take input B, it goes off. And I also have a clock circuit in here. I have this clock set really slow, half period of 50, whatever time periods they're looking at. But I can change that. I can make it really fast. I don't even know if you can see that on the computer. I've done it slow so to make sure that we can see what's going on. But I have here, I've put in a D flip-flop and I put in a JK flip-flop. And you saw the video about the D flip-flop. And here you can kind of see the difference between the D and the JK. So if I hit A, it has to be on the rising edge whenever the clock goes from 0 to 1. That's whenever the output comes on. And it's the same on both. The J is 1, so that's a set. Now when I take this off, whenever I click this off, it has to wait until the rising edge, boom, the clock went to a 1, and that one went away, but this one stayed. And it's going to stay until we do that. And if you want to see the toggle function, you can put them back on, and you can see on every rising edge, it would toggle. So you can play around with this. These connectors is the way you want to do your circuits in Cedar Logic. It makes everything a lot more neat, easy to see what's going on. You don't have lines everywhere, and if you have to delete something, then you don't delete everything. All right, well, you can see the functionality there, the D flip-flop, the JK flip-flop. We looked at excitation tables, function tables, and hopefully that gives you a good start on how to handle these things. And we will end the video there.